Architecting a database can be really tricky, but the most important thing to get right is that you've modeled your one-to-one relationships, your one-to-many, and your many-to-many relationships accurately. If you do that, everything else will start to fall into place. Let's talk about it. So there are really three different types of relationships that we can have between entities in our database, right? We've got one-to-one, one-to-many, and many-to-many. And to draw that out, looks something like this. If I have one of entity number one, it relates to one thing of entity number two. Right? Another thing of entity number one, it relates to exactly one other thing of entity number two. You get the idea. Right? One to many would look more like this. We have some things of type number one or of entity number one, and they might relate to three different types of entity number two. This second one might relate to two. This third one might just relate to one, right? It's really one to zero to many, right? We might even have one that doesn't relate to anything there. Okay, cool. And then a many-to-many relationship is exactly what it sounds like. We'll have all these different instances of thing number one, some instances of thing number two, and we can have kind of multiple relationships going on at the same time. Now, let's start simple. Say we have in our database a users table. Actually, let's go with students, a students table. Be a little bit more specific. And in the students table, we have two fields. A student has an ID, and a student has a name. Let's say we're thinking about adding a new entity to our database, and this entity is a GPA, right? A grade point average. And we're trying to decide how we're going to relate a GPA to a student. Well, once we decide that it's a one-to-one relationship, meaning a GPA and a student are tightly coupled to one another, right? A student has one and only one GPA, and that GPA is related to one and only one student, right? If that's the case, then it's pretty simple. We just add a new field, right? We just add a new field called GPA. Generally speaking, with a one-to-one relationship, it's easiest to model that as just another field on a database table. There is one other option though. What we could do, and I would argue this is typically a little less common because it's a little more complex, but I've seen it around, is that we'd create a new table and we might call it something like, I don't know, student credentials, or maybe student scores. And in this second table, we would have essentially the same ID. And the reason we'd have the same ID is to make sure that this relationship remains one-to-one. We at the end of the day, we want to make sure that both of these tables have the exact same number of records so that one record in one table will relate to exactly one record in the other table. And we would typically do this for organizational or performance reasons, right? It's that we want to take this field here, the GPA field, and move it into a new table and kind of keep it separated physically and logically from the students table, right? And it would give us some flexibility. Maybe we have some other data in here, like a test score, that we'd want to add as another field on this table. So one-to-one relationships, generally speaking, it's just a field on the same database table, but it might be a kind of one-to-one mapping of primary keys between two tables. Now let's talk about one-to-many. Now, one-to-many tends to be the most common type of relationship that you'll see in web development, right? Imagine a user and their tweets, right? You have one user, and that one user can have 0 to many different tweets that they've authored. Let's go ahead and model this out. So let's say that users have an ID and a name. Seems pretty straightforward. And then tweets will need an ID, some text, and now's the tricky part. We actually need to model the relationship between tweets and users. So keep in mind, a user can have 0 or many tweets. When this is the case, the easiest thing to do is to put a foreign key ID on the entity that is the many. So in this case, the tweets should reference the users. So tweets need a user ID. If you think about it, it starts to make sense, right? In fact, let's just jump right into some examples. Let's say that we have a user number 1, name Lane, and user number 2, ID 2, name Alan. And then a new tweet is created. ID 1 says hello. And let's say Lane tweeted it. So it will be user ID 1, right? It references Lane over here in the users table. The next tweet will, of course, be ID 2, because we need all of the IDs in the tweets table to be unique, right? They're the primary key. But the user ID on this one, say it's hey, might be user ID 2, right? So Alan tweeted this tweet. Now, when we add a third tweet, let's say Lane tweeted this one again. We could just reference Lane again, right? So we can have many tweets, right? In this case, tweet number 1 and tweet number 3 that are related to one user, right? User number 1, which is Lane in this case. So one-to-many relationships, foreign key on the table of the many. Now let's talk about many-to-many. This is arguably the most complex relationship type, many-to-many. Users and tweets don't really make sense. So let's change out the tweets table for something else. Let's do groups. So let's say that users can organize themselves within groups. And if you think about it, this starts to make sense, right? A user should probably be able to be a part of many different groups, but a group naturally can have many different users in it. So we've got a many-to-many relationship. Okay, let me move these apart just a little bit. Now, a group is going to have slightly different data. A group should probably have a name. I guess that makes sense. But just to keep it a little unique, let's say that a group also has a size, like a max size. Okay. And let's add a couple of groups. So we can still use Lane and Alan, but we'll create a new group, call it Gophers, and it has a max size of 20. Then we'll create another group, Pythonistas, max size of 30. Okay, got a couple groups. And actually, just so that they're different, let's add a third group. No, let's add a third user. That'll be good. So this will be user number 3, name him John. Okay, now how do we model a many-to-many relationship? The problem is we can't use a foreign key, because if we just add a foreign key to the group, we'd be stuck with a one-to-many relationship. We'd have no way to relate multiple users to multiple groups. We'd only be doing multiple groups to one user. So the approach typically here is to create a new table. So we actually have to add a third table here in the middle. And this is typically called a joining table. And really its only purpose is to model the relationship between users and groups. And oftentimes you'll see the table just called, for example, user groups, right? Very obviously just kind of mapping the difference or mapping the relationship between users groups, right? Users and groups. Okay, what would actually be in this table? Well, typically there's just two things in this table. There is a user ID and there is a group ID. Right? So just two foreign keys make up this table. And typically you'd put a constraint on this table and say, we are not going to allow two rows in this table to be identical. Let me show you what I mean. So let's say that Lane joins the Gophers group. When he does that, the way we're going to indicate that he's joined is by adding a new row to the joining table that says user ID 1, group ID 1. Let me add some spacing there. So user ID 1, group ID 1. Now let's say that Lane also joins the Pythonistas group. So we do user ID 1, group ID 2. Now, what I was talking about constraints earlier, what I mean is we wouldn't allow a second row to be added here that's identical to this other row because it's just fully redundant. It's telling us the exact same thing, right? That Lane has already joined the Pythonistas group. So we wouldn't do that. But let's say that Alan joins Pythonistas as well. So now Alan's in the Pythonistas group, right? And maybe John joins the Gophers group. Okay? So notice the many-to-many relationship here, right? Lane has now joined both groups, Gophers and Pythonistas, right? But the Gophers group also has 2 different users, right? It has Lane and it has John. So by using a joining table, we're able to accurately model a many-to-many relationship.